Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will solve non-monic quadratics. So we looked at a previous lesson at solving equations like this: x squared minus 6x plus 9 equals 0. So this is a quadratic equation, quadratic because of the x squared term, and equation because of the equal sign. So we decided we didn't want to try and move everything over to one side, get x by itself. If we try that, we'll be there all day and won't get anywhere. Instead, what we did was factorize this and use the null factor law. So we found two numbers that multiply to minus 9 and add to minus 6, which were both minus 3. And then the null factor law says either the first bracket is 0 or the second bracket is 0. In this case, the answer is x equals 3. So this is a monic quadratic because the number in front of x squared is 1. But what about when the number in front of x squared is not 1? Well, let's say we had something like 3x squared plus 30x plus 48 is equal to 0. So the number in front of x squared isn't 1, but this really is like a monic quadratic. Why is that? I can simply take out a common factor of 3, and then I can divide each side by 3 to make this monic. So if I divide each side by 3, I just get a monic quadratic. And that's really easy to solve. I just find two numbers that multiply to 16 and add to 10. And of course, my solutions will be x equals minus 2 and minus 8. Because if x plus 8 is 0, x is minus 8. And if x plus 2 is 0, x is minus 2. So that's all well and good, but what about when we can't do this? This example here, 2x squared plus x minus 15 equals 0. So for simplicity, we're going to call a the number in front of x squared, b the coefficient of x, and c is going to be the constant term. So in this case, a, the number in front of x squared, is 2, the coefficient of x is 1, and the number by itself, the constant term, is negative 15. So this is an example of a non-monic quadratic. Now, it is a quadratic because it has an x squared term. It's non-monic because the number in front of x squared, which I've called a, is not equal to 1. Now, in this example, we can't use the previous trick. We divided each term by 3 in the previous example. We can't do that here because A, B, and C have no common factors. I can't take out a common factor and make this into a monic quadratic. So therefore, I'm going to need a totally different method. So I'm going to follow these 4 steps in red. And these 4 steps will allow me to factorize this expression so that I can then use the null factor law just like I did in previous lessons. So the idea, the goal here is the same. We want to factorize so we can use the null factor law, but the way we factorize is just a bit different. So let's go through these steps with this example. The first step is to calculate AC, A times C. Well, A is 2. And C is negative 15. So AC here is negative 30. So now what we need to do is we need to find two numbers that add here to B, which is 1, and they multiply to AC, the number we just calculated. So we want to find two numbers that add to 1 and multiply to negative 30. So those two numbers in this case, two numbers that multiply to negative 30 and add to 1, will be negative 5 and 6. So the next step, 3, is to split up B accordingly. So we take this term and we split it up as these two numbers. So what I'm going to do down here is I'm going to rewrite my expression. So I'm leaving the first term the same, but I'm writing B, the B term, x, as 6x minus 5x. I used 6 and minus 5 as the coefficients because they are the two numbers I found in step 2. And now I'm going to leave the last number the same as well. So step 3 is done. Now what I'm going to do in step 4 is I'm going to factorize by grouping. So you factorize the first two, then you factorize the second two. So for the first two, 2x squared plus 6x, the highest common factor is 2x. So What do I times by 2x to get 2x squared? What do I times by 2x to get 6x? So I do the same for the second two terms. The highest common factor is minus 5, and then in the brackets I get x plus 3. So what should happen if you've done the steps right is you end up with two brackets that are the same. So what I sort of have is like one term here and one term here. The highest common factor of each term is what is in the brackets. So I write what's in the brackets out the front, and then I write what's left in the other bracket. So I get 2x minus 5. So now I've successfully factorized this expression here. It's x plus 3 multiplied by 2x plus 5. Now, once you've got to this step here, it's easy. You know what to do. You use the null factor law. Either x plus 3, the first bracket, equals 0, which means x equals minus 3, or the second bracket equals 0. So if 2x minus 5 equals 0, you add 5 to both sides and divide by 2. You get x is 5 over 2. So the two solutions are x equals 3 and x equals 5 over 2. So this is complicated and takes some getting used to, but once you follow these steps, it's just like what we did in previous lessons. So let's look at another example. So please pause and copy this down if you need. So let's look at solving this quadratic equation here. 8x squared equals 10x minus 3. So remember, we solve quadratics, we have to have one side equal to 0. So I'm going to subtract 10x from both sides. And then I want one side to be 0, so I'm going to add 3 to both sides. So I get 8x squared minus 10x plus 3 equals 0. Now, hopefully you see this is very similar to the example I just did. We have a quadratic trinomial. It is non-monic because the number in front of x squared is 8, which obviously isn't 1. There are no common factors of 8x squared minus 10x and 3. There are no numbers that go into all three terms. So what we're going to do is use the process that I just went through. So in this equation, A, number in front of x squared is 8, B, the number in front of x is minus 10, and C, the constant term is 3. First step was to calculate AC, so that's just 8 times 3, which is 24. My second step, I want to find two numbers that add to B, so in this case minus 10, and that multiply to AC, which is 24. So I want to find two numbers that multiply to 24 and add to negative 10. So if you don't know, go through factors of 24, and you should get that the two numbers I need are minus 6 and minus 4. Minus 6 plus minus 4 is minus 10. Minus 6 times minus 4 is 24. So remember that what I do now is split up B. So I take my equation, 8x squared, leaving the first term alone, and I split up B into minus 6x minus 4x, okay? Because minus 6x minus 4x is minus 10x. If I add the 3 at the end, I haven't actually changed the expression. This is exactly the same as this. Now, just so you know, it wouldn't matter if I switched the 4 and the 6 around. If I wrote 8x squared minus 4x minus 6x, I'll still end up getting the same solutions. Because I haven't actually changed the expression, this is still equal to 0. So remember what I did in the previous example? I factorized the first two terms and factorized the second two terms separately. So let's do that. So 8x squared and 6x. The highest common factor is once again 2x. So I take out 2x from the front. So I times it by 4x to get 8x squared, times it by negative 3 to get negative 6x. Now, if I look at the second two, they don't actually have a common factor. So what do I do? Well, I can take out a common factor of negative 1. So I'm taking out negative 1 because this is a negative here. So if I take out negative 1, I'm left with 4x minus 3. So once again, notice I should get the same bracket appearing more than once. So that is still equal to 0. So again, I factorize by using highest common factor again. The highest common factor of this thing and this thing is what's in the bracket. So I write that at the front. And then what's left goes in the other brackets. 2x and then a minus 1. So I've actually factorized this. So once again, I just use the null factor law. So I have either the first thing is equal to 0. So 4x minus 3 equals 0. You add 3 to both sides and divide by 4. You get x is 3 over 4. If the second thing equals 0, 2x minus 1 equals 0. Add 1 to both sides and divide by 2. You get x equals a half. So the solutions here, x equals a half and x equals 3 over 4. There's never more than 2 solutions, so I know I'm done. Alright, thank you so much for watching this video. This has been the luckiest maths teacher in the world. Have a great day.